Hi, welcome back to Lussac Chemistry. This is Lussac Gas Law Lesson 1. Okay, so let's look at our pressure unit conversions first. The flow goes 1 atm equals 760 millimeters of mercury, which equals 760 torr, which equals 101.325 kilopascals, which equals 101,325 pascals, which equals 1.013 bar, which equals 14.7 pounds per square inch. STP is, of course, 0 degrees Celsius and 1 atm. 1 millimeter of mercury is equal to 1 torr. K equals C plus 273.15. 1 milliliter equals 1 cubic centimeter. Gay-Lussac's gas law is P1 over T1 equals P2 over T2, but better written as P1 T2 equals P2 T1, and our volume this time will be our constant. All right, so let's look at what we got here. A gas has a pressure of 0.307 atmosphere. So we're going to go ahead and do that. There we go. At 50 degrees Celsius. And we already know that we need to convert that. What is the pressure at STP? So now our standard temperature is going to be 0 degrees Celsius. So we want to know what the new pressure is going to be. All right, so let's go ahead and K equals C plus 273.15. Well, for T1, that would be 50 plus 273.15. So T1 is going to equal, let's get the calculator here, 50 plus 273.15, which equals 323.15 K. All right, that's pretty darn amazing. Our T2, guys, it's 0 Celsius, so that's going to give me 273.15 K also. All right, so let's go ahead and solve this. So we want to isolate for P2. So P2 equals P1 T2 over T1. So P2 equals, of course, P1 is going to be 0.370 atm times our T2, which is 273.15 K, divided by our T1, which is going to be 323.15 K. The K's will cancel out, and our P2 will be the following. So let's go ahead and do our math. 0.370 times 273.15 divided by 323.15, and we get 0. Looks like here we're going to get this. It's going to be, of course, 0.31. 0.31 atm. Looks good. Okay, a gas cooled from 223 Kelvin to 273 Kelvin. So the initial temperature was 323.0 Kelvin. Yeah, it doesn't look like a good 3, but you know what the heck. It gives me 273.15. Okay. And then our original pressure was 750 millimeters of mercury. And of course, what is our new pressure? Isolate for P2. P2 equals P1 T2 over T1. So we go P2 equals P1, which is 750 millimeters of mercury, right? Yep. Times our T2, which is 273.15 K, divided by our 323.0 K. And again, I'm sorry I made a messy 3 on that earlier, but we know what it is. So let's go ahead and do the math here. Take 750 times 273.15 gives me that number, divided by 323.0, and that's going to give me 600 and, of course, 34, it looks like. Yes, 634.25 ATMs. Or millimeters of mercury, actually. 634.25 millimeters of mercury, which is actually less than an ATM. Okay, guys, well, listen, you be snarly, and we'll see you back here at Musin Chemistry.